In recent years, acceleration of the trend to electronically control the units used in home appliances and automobiles is calling for an increased need for temperature management using thermal sensors. Within the field of industry and energy, especially for devices such as batteries and power semiconductors, monitoring for abnormal overheat significantly impacts safety and reliability. Driven by a magnetic circuit, which is an integration of our unique temperature-sensing ferrite technology, reed switch, and permanent magnets, KEMET's thermal sensors are thermal switches supplied to our customers for nearly half a century. KEMET's thermal sensors do not need driver circuits unlike thermistors, and it simplifies system design and enables on-off operation with a minimum number of components. Let's take a look at Thermorite, a temperature-sensing ferrite developed by KEMET. There are two types of ferrite materials, hard ferrite and soft ferrite. The temperature-sensing ferrite is a material that uses manganese-zinc soft ferrite and developed utilizing its characteristic to lose magnetism rapidly when it reaches Curie temperature. Curie temperature is the temperature at which magnetic material lose their magnetic property rapidly. The temperature-sensing ferrite has reversibility, and it loses magnetic property above the Curie temperature and recovers its property below the Curie temperature. Thermorite has three main features. No degradation of the material over time, as the Curie temperature is determined by formulation of the material. Flexibility in shape forming, as it is a ceramic. Durability against humidity and hazardous gas. KEMET's Thermorite can convert to mechanical energy utilizes for its magnetic circuit in different temperature. Another key component of KEMET's thermal sensor is the reed switch. The reed switch is an on-off switch operated by an applied magnetic field using coils or magnets. It has a pair of magnetic material strips such as iron-nickel alloy and is hermetically sealed into a glass capsule with inert gas inside. With the presence of the magnetic field, the two reeds sealed in the glass capsule become magnets of opposite poles, thus attract each other and make contact. When the magnetic field disappears, the reeds separate and the contact breaks immediately. The reed switch is superior in longevity and environmental resistance because the glass capsule protects the contact part from the external environment. Combined with magnetic coils or magnets, reed switches accommodate sensing and switching for many purposes and are used in a variety of applications. The thermal sensor has a simple basic structure. The break type has a ring-shaped thermorite slid onto a reed switch, and the thermorite is sandwiched by a pair of ring-shaped permanent magnet. The whole assembly is fixed with adhesive. The make type has two ring-shaped thermorites separated by a spacer slid onto a reed switch, and the thermorite is sandwiched by a pair of ring-shaped permanent magnet. Let's shift our focus to the operation principle of the thermosensor. Simply put, it is a thermal switch that opens and closes the contacts within its built-in reed switch by the shift in magnetic energy of thermorite and permanent magnet. Here, a ring-shaped thermorite is in the sensor, sandwiched by two ring-shaped permanent magnets with polarity arrangement as shown, with a reed switch fixed inside the rings. When the temperature of the thermorite is at or below its Curie temperature, it functions as a magnetic body. In contrast, when the temperature exceeds the Curie temperature, it becomes a non-magnetic body. This change in the characteristics shifts the magnetic circuit, which makes or breaks the contact in the reed switch. The thermal sensor has two types of switching action, break type and make type. The break type's mode is normally on that is turned off at the operating temperature, as opposed to make type, which has a mode that shifts from off to on. Make type is developed utilizing a magnetic circuit structure that maintains a normally switched off condition. Now the thermal sensor can have normally closed or normally open contacts that can switch on or off at a specific operating temperature. These graphs show characteristics comparison between KEMET's thermal sensors and standard bimetal sensors. The left graph shows temperature accuracy versus operating temperature. The right graph shows differential temperatures. Bimetal sensors tend to have accuracy degradation as the operating temperature gets higher. The benefit of KEMET's thermal sensors is that they have a narrow differential temperature, regardless of the operating temperature, which allows them precise temperature control. Let's take a closer look at the benefits of KEMET's thermal sensors and their usages. The benefits are: use of the reed switch eliminates the need for driver circuit. Temperature sensing with superior repetitive accuracy. The narrow gap between operating and reset temperatures. No aging deterioration. Product life depends on operating life of contacts in the reed switch. No self-heating. As shown here, the main two usages are temperature control and overheat monitoring. The benefits not only increase the accuracy in the temperature control of heaters or fans, but make the thermal sensors optimal in overheat monitoring, where high reliability that ensures operation at the onset of abnormality is required. The product lineup of KEMET's thermal sensors is comprised of two series: TRS series that has an operating temperature tolerance of plus or minus 2.5 degrees Celsius, and OHD series that has the tolerance of plus or minus 5 degrees Celsius. The TRS series is available in lead wire type and terminal type, offering two options in mounting method, while the OHD series comes in three types: OHD1 and OHD5R series for mounting on boards, and a series for direct mounting on devices itself. The use of reed switches in these thermal sensors allows a broad range of rated power from light load to 60 watts. TRS series has a maximum rated power of 60 watts. For OHD1 and OHD3 series, the maximum is 6 watts. OHD5R series accommodates a maximum of 1 watt. KEMET's thermal sensors can be mounted onto a location near heat sources for the best result. A variety of applications calls for a variety of operating temperatures that need to be detected. KEMET's thermal sensors allow users to select the operating temperature that best fits their usage, from a broad range of -10 to plus 130 degrees Celsius. Today, we see an increasing trend in the number of heat-emitting parts, such as power semiconductors. KEMET's thermal sensors will continue to be the best device to monitor and control these parts.